All right, we got one last section here in chapter 6, and we're going to get after it. This is going to hopefully be quite a bit of review. The only thing we have to remind you is what does the square root graph look like? And remember, that means the square root of 0 is 0, the square root of 1 is 1, the square root of 2, decimal 3, decimal 4 is 2. So we're going to be dealing with the top half of this parabola. What's the other half look like? We don't have this dashed line, but that's how you want to think about it. And what we're going to do is we can stretch that to make it taller, just like we had worked with before. We can shrink it to make it shorter. We can use an x-axis reflection to flip it over. We can translate it left and right. Remember, left and right is opposite of the number that you see here. That's how we came up with the domain. And we can move it up or down. And this one is true to the number we see. The other thing we're going to work with is the cube root. So we're going to give you the parent right now. So the cube root is going to look a lot like the square root, but we are going to have a pinwheel on the left side because I can take the cube root of -8, it's -2. Okay, so these are going to continue back to the left. We can flip it over, we can make it taller or shorter, we can move it left and right, and we can move it up and down. It's just a new shape. Okay? So domain and range of the square root is going to be based on your starting point. Okay, often we're going to go to the right here in Algebra 2. So that means your domain is going to be x is greater than or equal to 0 for this one. And since this one is going upward, not downward, then your range becomes y is greater than or equal to 0. But it's all based on your starting point, 0, 0 down here. Now with your cube root, the other one we're going to look at today, just to get all of it out of the way, the domain is all real numbers. Notice we're going to go left and right forever. The range, it's also going to continue up, albeit slowly, and down, so all real numbers. So those aren't going to be too bad to work with, but that's kind of the rundown. Okay, so one more review before we really get into it. So when we're dealing with, remember the old absolute value of x minus 2, and then plus 3. So remember, x minus 2 is going to take it which way? Good, it's inside, so that's right 2. Plus 3, it's going to take it which way? Good, up 3. 1, 2, 3, and this one has a V shape that we would use from there. It's going to open up because we had a positive in front of it. Okay, so all these translations are going to work the same way, just a brand new shape. So hopefully you find some relief in this one that it's not too bad. All right, so we're going to take this, and if it says x minus 3, that means we're actually going to go right 3. So I got 1, 2, 3. I'm not worried about where that is just yet. And up 5. These are my two translations. So 1, 2, 3, 1, 2, 3, 4, 5. So this is now the beginning point. It's a regular size because there's no a value. And it is positive, so we're going to make this thing go up. So my domain, x is greater than or equal to, and here's where I think it is helpful to write the ordered pair right here. So that ordered pair is actually 3, 5. The x value is 3. The range is going to deal with 5 because that's the y value, and it also goes up, so greater than or equal to. So that's how we handle dealing with those domain and range as we get a translation. So hopefully you're saying, I remember a lot of this, and that's a good thing. All right, the next one says plus 1, so which way we're going to go? Left 1, excellent. The minus 2 is going to take it where? Down 2. So left 1, down 2. Here's our beginning point. At checkout in front here, there's nothing, which implies a positive 1. So I'm going to go up 1 and over 1. I could continue that just a little bit to get the idea of the square root of 4 is 2. So what's this ordered pair? That's always the important thing for domain and range. So one practice that I have is often to write that. So it's -1 with -2. So the domain, x, is still going to the right. So it's greater than or equal to 1. The range is still going up. So it's greater than or equal to -2. Oh, almost forgot my negative on the 1 there. All right, since these aren't too bad, let's add just a little bit to it. So first things first, we're still going to translate them to find out that vertex point, starting point, as we always have. So x minus 2, which way are we going? Right 2, excellent. Minus 3, down 3. So right 2, 1, 2, 3, down 3. Here we are. What is that? Ordered pair? That ordered pair is negative. Oh, I didn't go negative, did I? Sugar and spice. Right 2 is over here. 1, 2. 1, 2, 3. There we go. That looks so much better. That was what we used to call a oopsie daisy, but it's all set now. So we're going to go right 2. Right is to the right, not to the left. Down 3. All right, so that means we have 2, negative 3 is my ordered pair. These numbers are going to be super critical with domain and range. As a matter of fact, I can set those up over here, but notice what's happening. Now it's an x-axis reflection. That's our academic vocabulary we've used all year for upside down. The 2 is going to make that taller, so that means I'm going to go down 2 and over 1, and this would continue way down as we look at that next set of points. All right, so we are going to go to the right. So to the right is greater than or equal to 2, right? I have values at 3, 4, 5, 6, 7, right? I have all these values to the right. The y, now that it opens down, this x-axis reflection means it's now less than or equal to negative 3, right? Negative 3, negative 4, negative 5, y values are going down. All right, let's try that again, because I almost messed it up. So I can only imagine how you feel about it. So here we go. Now inside, there's nothing going on. So that means left and right has a movement of 0. So I'm at 0, and the outside is down 3, down 3. So 0, 1, 2, 3. Oop, there it is. It's going to open down. Okay, so domain x has to do with 0. The range y has to do with negative 3. See how all these things are all tied together? They're like shoelaces. They're so tied together. So down 1 over 3. That means it's going to be squished this time. So I'm going to go down 1, 1, 2, 3. That's where it goes. All right, so we hit that point. So I'm still going right, right. So because I have 0, 1, 2, 3. So that means greater than or equal to 0. Negative 3, negative 4. Eventually it would make it to negative 5, less than or equal to negative 3. So you got it. This x-axis reflection has a major change on your range to make it less than instead of greater than. All right, in pre-calc, we're going to start flipping these and make them go left, not in algebra 2. All right, so that's a regular square root. So that's the one you were somewhat familiar with because it really pushed you along when we did have school. Well, this is still school. When we did have class, and I saw you every day in those translations. So let's take a look at cube root. So remember, this thing starts off looking almost like the square root, but also has the left-hand side. And I'm also going to not ask you about the domain and range over and over because we know it's all real numbers. So just keep that in mind, as by the end of the week, we are looking at a test. So you want to make sure that we have that idea down. So plus 1. All right, keep me honest here. Which way does it go? Left 1. Good. So left 1 minus 4 is down 4. So let's go left 1. I actually went left this time. 1, 2, 3, 4. Where is that? That is at negative 1, negative 4. You know what? We don't even need that, but it's a good habit. So that's what we're going to do with it. All right, the 2. Now we're going to make it a little bit taller and make this thing happen. So that means the cube root of 1 would be 1. So I'm going to make it jump 2. Okay, and as long as I'm making that a little bit taller, and then I'm going to get the reflection kind of side of it on the left. Oh man, I missed both those points. That's all right. You can see it, I had them there, so I'm trying to reach those points to make this thing a little bit taller because of that 2 is going to stretch this graph out. Okay, but the big key is in that cube root, now I want to use that negative left side to deal with. All right, now these things start to get a little bit weird. because, you know, sometimes if I didn't type it, if I hand wrote it, you wouldn't be able to tell where the end of this thing is. So often what you'll see is all these things get flipped around. So this plus 3 over here actually means that you're going to move the graph up 3. This negative 1/2 right here means an x-axis reflection, and A is 1/2. Okay, so that's a vertical compression, right? We'd say vertical compression, A is 1/2, x-axis reflection. And it's not until I get way over here that I realize this thing is going to go right 2. So that's what we're going to get right 2, 1, 2, 3, up 3. So 2, 3 would be my vertex. Again, why'd I write it? I don't know. Habit. It's a good habit. Right? And if I was dealing with domain and range, that might be a number to use if it were a square root. But it's a cube root. So this time it's going to go down. So I'm going to go down 1 and over 2. And I'm going to use its reflection. So up and left. So I'm going to get this curve here and the top side of it there. And it's been squished, right? We've taken that regular curve and we've squished it. That's what we're trying to do right now. Right? But we did the translation to move it around. All right, so a little bit different as far as shape, but not doing too much with it. All right, we have a little activity here, just dealing with square roots and cube roots, but really working with the greatest common factor. So when I look at the greatest common factor of 9 and 9, so 31 can actually be rewritten, because right now a lot of these, you can't really tell any translation about it because we have a coefficient on the x. So here's what we're going to do. We're going to take this 9 out and make it x minus 1. Now what I can do is I can take that 9 and the x minus 1 and pull them apart. So what's the square root of 9? Yeah, it's 3. So now I've taken this graph that said 9x minus 9, take the square root of it, and now I can say it's actually a stretch of the graph by 3, and it moves to the right one. So that's what these things are about. And if this ever happens, it's really helpful to deal with the graph that way. So 16 and 32, GCF might be 16, okay. X plus 2, what's the square root of 16? So y equals negative 4, and then x plus 2. All right, so you get the idea. So we're going to omit the ones on the end here. But we can move this up and talk about 34. This time we're looking at the cube root. But the idea is the same. If I don't have one x in there, I'm looking for a GCF because I want to make this a little bit easier. So this time we have the cube root. So 64 and 128, you guessed it. They're both divisible by 64. So I have x plus 2. Now what's the cube root of 64? Remember, that was one of the things we had to memorize earlier this year. Wouldn't let you in the room until you knew it. So the cube root of 64 is 4, and it's the cube root of x plus 2. And the last one, 35, even though there's a minus 3 on the end, we're just really focused on what's happening inside of there first, and then the translation on the end. Notice we went back to a square root, whether that makes this easier for you or not. So 25 and 125, you guessed it. 25 is the GCF, so it's x plus 5, and then a big old minus 3 after that. Remember, that's on the outside. So it's the square root of 25. 5, good. X plus 5, and then minus 3. All right, so if I want you to describe what's happening here, you would tell me that it is a vertical stretch. You would tell me that it goes left 5, and you would tell me that it goes down 3. When we first look at 35, it doesn't look as clear as it does down here in the answer. So that's why we want to make sure that we can rewrite these when possible. Doesn't happen all the time, but when it's in front of you, it's definitely something we can do. All right, quick review here. Number 7, what happens to the graph since we have plus 1? Number 12, what happens to the graph since we have plus 1 on the inside? Question number 3, what are the two things that need to happen to number 16? We have negative on the outside, and we have x minus 1 on the inside. All right, last question to make sure we have it. 29. What are all the things that we need to describe for number 29? We have multiplied by 2, what's it mean? We have x minus 6, what's it mean? And we have minus 9 on the outside, what's it mean?